Que pasa, Mufasa? We're going to try properties of logarithms. This is section 3-4. We've been talking about logarithms. We're going to talk about it a little bit more today, and we're actually going to skip the rest of this chapter. We're going to move on to other things. We only have so much time. If we tried to cover that whole book, it would take probably 2 years to cover everything in this book. So we're not going to do that. Just properties of logarithms, section 3-4. So let's check it out. Here are some properties of logarithms. Lovely. So log, this is, let's see, if you have log of AB as of the product of two different things. So the logarithm of A times B, whatever that is, well, that is equal to the logarithm of A plus the logarithm of B. So my note here is that I can change multiplication into addition. Multiplication into addition. And it works in this direction. It has to be multiplication on the inside of the parentheses, becomes addition on the outside of the parentheses. It doesn't work the other way around. If I wrote this with a times sign, I couldn't put a plus sign there. So keep that in mind. Keep these notes handy while you're working on the section, and that will be a good guide to you and make sure that you're doing it correctly. Next, I guess multiplication, we'll try division. So log of A over B, logarithm of that fraction, is equal to, well, subtraction. So log of A minus log of B. Okay, so here I'll say division becomes subtraction. Division and becomes subtraction. Division becomes subtraction. Look at that, I'm so colorful. Isn't that great? Wow. Okay, one more. Logarithm of A to the B power. Well, that's going to be B times logarithm of A. Okay, so my little note to myself here will be that, let me scooch that up, will be that the exponent becomes the coefficient. The exponent becomes the coefficient. Okay, so those are some things we can do. Let's go ahead and try a couple of problems using these properties of logarithms. Let's see. The first instructions will be to expand. Expand this. Expand log of 8xy to the fourth power. Okay, well, look at this here. I have multiplication, that's going to become addition, and the 4 is going to become the coefficient in front of the logarithm there. So let me start first by writing log 8 plus, multiplication becomes plus, log x plus y to the fourth. I'll move that exponent down to the coefficient in a minute. Plus, plus log, log of y to the fourth power. Okay, in my next step, I'm going to change this exponent into a coefficient. But before I do that, I need to make a little note right here that this 8 is really a power. This 8 is really 2 to the third power. So let me cross that off. And write that as 2 to the third power. And hopefully a number like 8 is small enough that you can recognize that it is just a power of some other number. I won't give you anything that's not too obvious, but 8 you should recognize. My final answer, make both of these exponents into coefficients. So 3 log 2 plus log x plus 4 log y. Okay, so in expanded form, this logarithm of 8xy to the fourth expanded out is that 3 log 2 plus log x plus 4 log y. Let me try one more. Okay, this is going to be natural log. These properties work just as well with natural log, so let me throw that in there. The square root of x squared plus 5, the square root of x squared plus 5 over x. Over x. Okay, well, I'll do this one in a couple steps as well. So let's see what we have here. This is equal to, let's say, natural log of the square root of x squared plus 5 minus natural log of x. Now, even though there's a lot of stuff in here, there's not too much I can do with it. Remember, let me scooch my notes up real quick. Multiplication inside the log becomes addition. But I don't have a rule for anything for addition inside the logarithm. So because I have addition inside the logarithm, I don't have any rules for that. So I'm just going to leave that alone. One thing I am going to do is that the square root is the 1/2 power. Square root is the 1/2 power. So I can write 1/2 natural log of x squared plus 5 minus natural log of x. And then I'm done. Okay? So that square root comes out. It becomes the 1/2 power. And that's it. That's all I can expand on that. So that's your final answer. Addition can't become anything. So leave that alone. One more bit of instructions here. It's going to be condense. Condense. Okay, this is the opposite of expanding. So I'm going to give you something in expanded form like this, and you need to work backwards to try to get them. Write it with just one logarithm. So let's look at this. 5 natural log x. 5 natural log x minus 2 natural log of x, y. Okay, so let's see. I have these coefficients. These are both going to become exponents, and the division is going to become a fraction. So let me go ahead and jump to that. I'm going to have my fraction in the numerator. 5 natural log x. Well, it's going to be x to the 5th power, and I forgot to stick natural log. Let me see if I can fit that in there. ln. There we go. So x to the 5th power in the numerator. And then it's minus this. So this goes in the denominator. Xy to the 2nd power distributes to both of them. So x to the 2nd, y to the 2nd. And I can actually, at this point, reduce the fraction a little bit. So let me do that. Natural log ln. Well, let's see. 5 minus 2 is 3. So x to the 3rd over y squared. So condensing that together, I get that. The coefficients became exponents, and I distributed that because it was in parentheses. The subtraction became a fraction, division. Because it was subtracting the whole natural log here, everything in this unit here goes in the denominator. So I've successfully condensed that. Here's my answer. Maybe I should circle my answer. It's all the way over there. Okay. One more thing I want to note is the change of base formula, and this is just a formula. I'm going to throw up here. It's fairly easy to use. Okay. You'll note in your calculator you only have 2 options, and my calculator isn't within reach, but there's only log and natural log. So let me tell you the change of base formula. Change of base. And every logarithm is just a multiple of another logarithm, so it shouldn't be too unintuitive that what I'm about to tell you is true. Okay, so if you have log base 2 of 7, you can evaluate that with either log or natural log. You could say log 7 over log 2. This is now base 10. Or you could say natural log of 7 over natural log 2. Okay, either one would work. So that's not too bad. That's kind of easy to do. Just make sure you use a bunch of parentheses, and you're good. So that's it for your notes for properties of logarithms. Those are all the properties I want you to know.